Oh, there's a lag. Is anybody else getting lag? Auto repeating itself? It might be me repeating myself. Never know. On a smoke break, huh? You gotta make it quick, or you could just smoke a whole pack, right? Well, no, don't do it. Don't do that, right? So typical switch. It's just one switch. There's no other thing. It's just one button. Looks like there is a reset. A small. If you can see the small reset right here. So I'm not sure. Yeah. It's a restart button. Interesting. Just like a reboot button, right? Restart the switch manually. It's not a bad idea, right? In case ever the stock firmware is hung up, you can just hit the restart button instead of having to go do the breaker. Okay. Well, appreciate the update there. So we'll pry the faceplate off. And first thing I wanted to see, this is a screwless faceplate. So I wanted to see if it fits in a regular Decorah plate. Give me a second. It's a regular Decorah plate here. It looks mostly like a standard white one, but I'm going to see if it's going to fit. Yeah, it actually looks. So that's kind of the thing. I know I messed with that first Tuya dimmer. They just didn't fit the exact faceplates correctly. So that's kind of one of the things I always check. That way it fits the regular stuff, so you can put them by other switches and stuff. It actually will fit. It doesn't have any big brackets or anything like that. It'll fit fine. So we're good with that. All right. Take out the warning sticker. And all right. So it looks like probably there's no screws on this. This is probably tied into the ground. It should just pop. A lot of these just pop open. See if we can pop it open without breaking it. Or let me find my blade, and so I can cut myself open, right? Live on camera. That'd make for a lot of views, right? Alright. Got one side popped. Alright. So it looks, yep, just as expected. That's mounted to the, bend it a little bit, but no big deal. The specs on them, I guess I should have covered that, right? Here's the specs on them. Let me change the focus here a little bit. Maybe y'all can see. So there's the specs on it. Looks like 100 to 240 volts, 50 to 60 hertz, and 15 amps max, which is well beyond what I'll need. Looks like max output 1500 watts at 100 volts. I don't know why they list 100 volts. I guess that's because the bottom. And then 3600 watts at 240 volts. And indoor dry use only, of course. So I think I just really need to get me like a big sword or something like that, right? That's how I use for my prying thing, right? So I'm just looking to see, match what's, let me change, like I said, I'm trying to mess with the focus here again. I'm trying to read what's on that relay. It actually, it's hard to read. Yep, it does say 16 amp, 250 volts on the relay is the rating. So we're gonna pop this, is actually a plug in here. We'll pop that off and split that out the way. So we don't really need that. So next, get the screwdriver. And I can already tell there's that module right here, that TOGGLE module. So there's just 4 screws. There's maybe some type of header, but it looks like 4 of them are just pads. If you can see right there, there's 4. Those 4 looks like they're just pads, and these 2 are some pass-throughs. So that may be what they're using actually to program it. But usually these TOGGLE modules, they're not too bad to solder to exactly. I guess I'll get the soldering iron warming up while I'm doing this. And I'm trying to look back and forth at the chat every once in a while and look back at the video. So bear in mind what my first time kind of doing this. So all right, looks like they're using the same mold as their dimmer or something else, because you can see there's 1, 2, 3, there's 5 like status lights, and you can see here's that restart button at the bottom. That's probably just shorting out something and pushing it to ground to cause it to reset. So we'll put that to the side here. Here's that. I'll go ahead and let me zoom in, bring the camera down closer since we're getting down. And give me a second here and I'll change the focus. It doesn't want to focus right exactly. And then it drives me nuts because it just focuses anyway. That should be a little bit better for you. Yep. Yeah, so it is split. It's just that one little plug-in. Looks like a little 3-pin DIN. Probably what they're, if I had to guess, they're just feeding over. Looking at here, they're probably feeding over 5 volts. And then probably going to get the 3.3 volts back to trigger, or maybe even the 5 volts. I know we can look at it and see what's triggering back, because you can see the power supply. Sorry about that. Let me move these screws out the way. You can see the power supply is actually on the board here, and it looks like there's the on-off button. I don't know what that says. D-Wi-Fi. That's what it looks like. D-Wi-Fi or something. I don't know what, but it's going to probably be a red and a green LED. And there's that AMS 1117. You see that power supply common on a lot of the Sonoffs and stuff. So, and I totally forgot running my mouth again. Let me turn my soldering iron back on. Yeah, I've got a dish or something for my screws somewhere, and it's funny, this screw didn't even stay in there. Supposed to be 4 screws. I didn't take it apart yet, so we'll just put those over here. So this module is kind of like I've already done a module like this before in a power strip, and I always refer back to my page I did on the Tasmota wiki. So let me pull that up here. Let's see, Tasmota wiki. I'll bring it over to the screen here in a second. Tasmota wiki, and I'll show you what I'm talking about. All right, we'll bring this over here. Shrink this and toggle. All right, so what I look for on here is under other devices, and the one I did here was the power strip, and you see it's very similar module. It's that same TYWE3S module. Yeah, I do have the switch, the link for the switch here, and there's like a 1-pack and a 2-pack. I think they were let's see, I don't know if it was any cheaper going the 2-pack or not. The 2-pack was $36, I believe. But we're waiting on the soldering iron to warm up anyway, so we can definitely check. Yeah, it was $36. I think you save $1 or something like that. Or what? 30. This was 18, and then the other, the 1-pack, the one I just sent. Yeah, you end up saving $1. It's $18.99 versus the 2-pack. So in case you want the 2-pack, was $35.99. I'm sorry. That's a good question. A lot of times what I'll do is, you know, if it's something that I may find that looks kind of cool on Amazon, a lot of times I'll look through the pictures of the actual switch, and let's see if I can find if this one's gonna have it. You know, the actual ones they put on Amazon, and then I'll look. Sometimes I'll look through the reviews, and I'll find somebody that has put and they just happened to put the switch, the back of the switch, on a photo or something. They were posting a review on the switch, and then I'll pull the FCC ID off of it, and then I'll go search the FCCIO page, and a lot of times they'll have like internal and external photos, and you can find the picture of it, and I'll show you let me pull this back over here. I'll pull another window over there. Let's see. This switch is the 2ANJ7-S01. And so I'll search the FCC ID page for it. If I get stuff mixed up here. And if you scroll down, you'll find under the exhibits, they'll have like the internal photos. And you'll find the switch and everything. And see, this is much just like what we were looking at here. And then I'm looking for, and they took the top of the can off of it. But, you know, it's like as soon as I see that, I know it's easy to, I'm like, okay, bingo, that's the ESP chip, that's the Tuya chip. And, you know, by looking at it, you can go, okay, look, there's some screws. It goes into the plate. Looks like it just pops right off. And so then you can tell, hey, that's definitely a doable one for me. Or just I may Google some of the switches and, you know, search, see if anybody else has done them. I'll look in the Tasmota wiki and see if, you know, they're in there, and go from there. Oh yeah, we haven't really done a whole lot, Phil. We've popped open the switch and unboxed it. We haven't got to the good stuff yet, I guess. So let's see. So basically, this isn't, you know, of course, isn't that exact one. Let me scroll down so y'all can see the picture. Move this over a little bit. And I got this picture from the Tuya website, and they do have it backwards. So I had to, what I did before I posted it up here on Tasmota wiki, I flip-flopped the pins to make it easy on you. And so what I do is just solder to each of these pins I need, which we just need VCC, the ground, the 0, and a TX and RX. Can you link that? Yeah, we don't want to lick the site. Yeah, if you just search for, and I'll post this exact one in here, the FCCIDIO. A lot of times I'll just Google for yep. I'll just Google for the like I'll put like the FCC ID. I'll maybe put like FCC space ID and space and then that FCC ID off the switch. That a lot of times I find people will post like the front and the back of the switch as they're installing it and stuff like that. So, and a lot of times you'll find those links. So let me flip back to the actual switch, and we'll go to here. Let's see if I'm missing anything else. Good timing, 2 Wi-Fi, so we have to be the same to your chip. Yep. Yeah, and you'll find a lot of people, a lot of different manufacturers always using those ESP chips. Which switches are those? So let's see if we can get this soldered here. And what I like to do is I'll take just some regular DuPont jumpers, your regular jumper wires, and I'll cut the other end off of it, and you can tell I've used this several times, and I'll just tin the ends of them, and I don't use the male jumper wires like this. Because what I've found is, say for instance, someone, you know, say if you're trying to solder to, I mean, let's just use these because it's a good example. You know, say you don't have a through hole type header, and I've seen people try to use these. And you can solder to them, but the problem is just the physics involved. Is now you've got this long thing sticking out here that now it's like, and I've seen people rip the pads off the boards using some male headers. And same thing with the male. I've seen also these used, the male DuPont ones. They're too easy to rip stuff off. And so I just find taking a jumper wire and cutting the end off of it and tinning it, it works so much better, and I've never had a problem ripping any of the pads off. Yeah, no, it's fine, Bobby. Ask all the questions away. I mean, that's kind of what this is. I know I may run long or whatnot, but hey, I've got no time schedule or whatnot. So, and other people might jump in there and answer your own question. But typically, all of the ESP chips, the ESP8266s and 8285s, they are going to be, you're able to, write your own firmware. What I do recommend, and we're gonna do it, even though I probably don't need to on this switch, is if it's a switch that you don't know that can be done, it's one that you're not sure of, no one else has done it, and you've Googled around and can't find anything on it, then I would back up the firmware, do a read of the firmware. Now, of course, if you're doing, and I don't do it, like if you're doing some Sonoff basics or something like that, I've got no intent ever to put stock firmware back on it. And I know for a fact that, the Tasmota or ESP Easy or your own sketch or whatever is gonna I'm gonna smoke break. Yeah, it better be a long smoke break. I talk too much. I back up the firmware if it's something I don't know of, because once you overwrite it and it's like, well, wait, nothing doesn't work, and you got to do a reverse engineer of some sort to see what's going on. Well, that's not going to help you any. You're not going to be able to go back because you overwrote the firmware. So you've always got something to go back to. So I'm just looking at the pinouts here of. Looking at the picture I've got on my screen, y'all can't see. This is TX, the top, and the second one down is going to be RX, and this one is GPIO 0. It's 1, 2, 3. It's 4 up. Yeah, it's GPIO 0. That actually might be tied to the button. I might get lucky. And then you've got GPIO 15, and you've got GPIO, that's the ground. So we're using 15 and 0 so far. So that's just a little easy way to cheat. Yeah, just by 2. That's also good. Easy way to cheat, not cheat, but just by looking at what they've actually soldered to. This one is VCC. Looks like GPIO 13. Actually, GPIO 13 looks like, because it goes to the switch here, that's going to be what the button's for. It's probably GPIO 13 if I had to guess. And then the top 2, it's reset. Well, there's your reset button. They actually tied the actual true reset button to the ESP reset. And then that's the EN pin. So we've got, looks like 13. I'm betting for that's the multicolor LED. Well, that's gonna be kind of cool, because some of the other switches, the red LED, like on those KU Lab ones, they're hardwired to the relay. So we may get lucky and actually have 2 different LEDs to play with instead of having one that's hard coded. So let's see if we can try to throw some solder on here. And my soldering methods aren't always the best, but they get stuff done. And I've never tried to do it. To do it at a little different angle here is going to be interesting, but we'll see if we can get it done. So the first one, you get this to lay pretty much flat. What I like to do is throw a little bit of solder on each pin. We get some to stick here. All right, there's that one. I'm trying not to shake the camera. Usually I steady myself on the actual magnification, but that's where my camera is at. Huh, interesting. I'm fogging up the camera. Didn't think about that. The next one, is going to be for GPIO 0. And then we need ground off the bottom. I'm trying to stay on camera here, guys. That was gonna stick on me. I got 0. And then we need VCC. I guess we could have probably cheated and used the red and the black, but we'll just go straight. I know this works, and so why buck the... I'd have had to go through the power supply if I did that. Alright. So that's that. You got some time to look at that plot light again I was working on. Yeah, possibly. You still got issues with that, Jay? Alright, so I'm going to do... Let's see how many different colors I have here. Let's go with orange. Let me try to fix the camera focus here. Let's see if that's a little better. All right. That one got a little mess on it. So one thing I gotta make sure that they don't stick together and that you hold it kind of still. But once you have solder on both sides, I find that all you do is you just stick a little heat to it, and that's it. They'll stick. Really simple. And hopefully I got that on camera, but we still got plenty more to go. We're going to do purple for... I painted myself into a corner. I wasn't paying attention. Need to get a little different angle on it, I guess. Oh, off camera again. Trying to not do that. If I can see. There we go. We got the purple. Can I multitask? It's hard to look at the screen and look at the solder at the same time. I'm definitely not as good as Doc. I have no idea how he keeps up with the chat and still keeps stuff flowing and no quiet periods, and I would fail horribly as a radio DJ announcer talk show. I can guarantee you that. So we got those two. Let's do, how about brown for GPIO 0. So that one, looking at the map, that's 4 up, or 2, skip 2, because that's 4, skip GPIO5 4 from the TX and RX. Alright, looks like we're solid on there. And we'll go with the gray. We'll go with gray for the ground. Make sure we on frame again. Got a little solder from last time, but we'll just melt it down. And Little tug, and there we go. So one left. And what colors do we have left? We'll go with yellow. Nope, yellow's not cut. Looks like we're getting blue for... Yeah, you're right. I haven't seen him. I think he doesn't do it. Yeah, right. I've seen on his videos he's done it. When he was making the zone off or whatever. Remember the command you gave me to change the LED strip light from 30 when you glance? Yeah, it was actually, I want to say it was pixels, as in plural, just pixels, space, and then the number of pixels. I think it defaults to 30 in that one sketch, their typical sketch. So now we got VCC, which will do the last one. The last one's probably going to be a booger for me, right? I don't burn everything with it. Let's see, that stay on there. Yep, we're good to go. And we'll turn this soldering iron off in a minute. And let me zoom in here right quick. Show you my wonderful sarcasm there. Wonderful soldering job. Let's see if that's going to focus for us. So we've got VCC here. And then the bottom right is the ground. You skip 2, which is 15 in GPIO2, and you pick up the brown is picking up GPIO0. Then you skip 2 again, and you're picking up the RX and TX lines that were used to flash. We could have figured out there was a button, but hey, I know this method works, and let's go for the surefire way, right? So, next thing to do is for GPIO0 to hold it to ground. What I do is just take a small header like this. Let's see if I can get the zoom. And I'll take it's too small for it. So I'll take a small header, and it don't have to be 5 wide. I think I had this one sitting there and it was just junk or whatever. And I'll just bridge 3 of them across. And what I'm doing that for is when we take the ground wire, and bear with me, I'll get this back on the ground wire, and which was gray, and then the brown was GPIO0, and we'll connect those together. And then when we go to flash, I'll just take another regular jumper and plug it to here. And the yellow is actually going to go to my flashing. So, and like I say, I don't like the autofocus on here. Let me fix this. If autofocus is fine when it's close, but I guess the grid throws it out of whack. So that's a really easy way to hold GPIO0 while you're flashing. So let's see if we can wire this sucker up. So yellow is gonna go. So we can read upside down. Yellow's going to go to ground. And orange is the TX, so that goes to RX on here. Then we had purple, which was the RX, so that's going to go to TX. Then we need VCC, which was the blue, without breaking anything and getting everything tangled up, right? But hey, we do it live. VCC. All right, boom. All right, we'll make sure they don't touch. We didn't tear up anything. No, we didn't break off VCC yet, but it's close. But we'll see. We'll see if we can get by, right? So we're gonna plug it in, and I'll bring up. Give me 1 second here. I didn't have that have that ready. What I'm looking for is Tasmota ESP tool wiki, and go into here. Yeah, I'm gonna bring this up on the screen for you guys in a second. The command prompt, and let's see, SP tool dash pcom 27, I think it is, and flash ID. Let's plug this in and see if the smoke comes out, right? Yes. 1 second. ESP tool. Dash P. All right. Bring this up on the screen here, and we'll flip flop display. So what I'm doing here is, check the chat. I was off the screen here. Definitely hell. A lot of times just add other pins and serials more than one to ground. No, Mike, you're not too late. We're just soldering and figuring out things. Of course, you'll always be able to rewind the video. I think it might let you right now, but of course, the chat will get confusing for you. But you're always welcome to go back and catch the beginning after you're done. So what I'm doing here is I want to do the backup, even though I know that 2-year module is a 1 meg module. What I would do is I'll run an ESP tool and put the port and put flash ID, and it'll show you that you get 1 meg flash. And it's important to note that once you've done that, the unit's not in flash mode anymore. So you will have to pull the power on the USB and then cycle it back in. So yeah, exactly. I should have had a bunch of switches, right, and had all the different little stages and show the magic of TV, right? That's no fun. We got to show how to do the whole process. That's, some stuff looks easy, but sometimes it's not. So what I'm doing is resetting, and I'm gonna copy this command in because I'm not. I copy and paste. I don't want to copy. We're gonna go, and this is right off the. If you go in the Tasmota wiki and you go to the ESP tool, they have all these commands right in there. And I'm just copying and pasting, and that's a really good page. It shows you how to back up the firmware and just change your COM ports and stuff. So we're reading the flash, and I'm gonna change the file name as well, and we'll call this the mjswitch1.bin, and we got it ready to go. Hit enter, and it'll take a little bit here. So of course we don't have video fast forwarding to fast forward time. Maybe if we had a flux capacitor or something, right? And y'all might not be able to see that. Let me shrink the, well, if I can shrink it small enough, right? Without, so there you can see it just clicks along. It shows you how much it's the firmware it's pulled so far. Qtc making video, you can use your phone as a remote, switch between the cameras. Let's see. Okay. Yeah, I just ran that in just dropped to a command prompt. And I'm using Windows here. But ESP tool is Python, so it'll run under whatever. You'll run Python, Linux or whatnot. I'm not sure exactly what all ESP tool supports, but I'm sure, I guess, because it is Python, it should support the gamut of everything. So once we've made a copy of the bin file, of course, again, it's not in flash mode again, so you need to cycle the power on it. And we'll cycle the power again. And if you really wanted to, I'm not going to do it here because we're going to bore ourselves. If it's something that I know is going to be weird, like some sort of dimmer or something like that, just out of safety's sake, what I do is I'll do 2 pulls of the bin file, and I'll do 2 different copies, and I'll run like an MD5 or something like that on to compare the bin files that they're the exact same. But it is important to do check the flash ID. Like for one case, these a couple random ones. I think the S31 has a 2 meg flash. The Shelly switches have a 2 meg flash. And so you'd want to, if you did that, you'd want to back up the entire 2 megs, not just the 1 meg flash. So, but you can just run your flash ID command and find the 1 oh, that's 1 meg. Yep, all I need to do is pull the 1 meg. And again, you can find those commands. And what I'll do is after I'll edit some of this video in not the video itself, but the description, and I'll put that in here. But here's the ESP tool link here. And like I say, it's straight off the Tasmota wiki. So if you just Google that, you'll find that. So we cycle the power. Let's pull up the famous ESP Easy, right? So we'll pull up Flash. I'll bring it over to the window in a second. The Flash ESP Easy Flasher. I'm on COM27. And the firmware I want is my firmware bin, which I usually compile my own Tasmota firmware. But of course, you'll just go to the regular Tasmota releases and download the regular Sonoff bin file and put those on. You'll use a Sonoff bin. There's just a couple things I have it trimmed down where it's just cut out a lot of the sensors that I didn't need on switches. I have my time zone set. There's a few other little different. I have my power retain set. It makes it easy. So we'll go ahead and flash this. I should have been flashing it while I was talking, right? But COM27, firmware bin, flash, and let's see. I'll pull it over here. And you know you got it when it shows all the little periods going back and forth. Let me flip back to the chat and see if y'all got anything else going on. Nope. Okay. So we'll hurry up and wait. How far we've been streaming so far? Cool. 49 minutes. Time flies when you're having fun, right? We'll have to try to go through this pretty quick, but we shouldn't be too bad. We just got to, I'll do a termite and throw my SSID and password in there. You don't have to. You could use the AP method where you like attach your phone to the access point and they'll go to that 192.168.4.1. So, not to interrupt, well, we got flash complete. Good to go. Okay. And we'll close ESP Flasher. And we're going to pull up. I got too many windows open over here. We will pull up Termite. And go to settings, COM27, hit OK. And sometimes I have to toggle it. And I don't remember if I toggled the switch itself after it flashed. But you can see now, let's just see if it actually, a lot of times I've seen it get stuck. If you didn't power cycle it, it'll actually be working. But then once it tries to do the reset, you will need to power cycle it. But we'll see here in a second. And I bet you I did get it stuck. But hey, we can try the reset button out, right? All right, y'all guys are talking. That's good. So let's try the reset button out on the switch. And I just burned my hand, almost burned my hand on the soldering iron. I forgot to turn it back off. Definitely don't need it anymore. All right. So there's a reset. Let's see if actually reset works. Oh, no, it's not going to. Because I'm holding GPIO0 to ground. That is the brown wire. That would keep us still in flash mode. All right, now let's try the reset again. All right, boom. Sounds like a plan to me. And now I'm going to take this off camera. Oh. Let's see. We'll do the backlog. And clear. And we'll bring this back on the camera. And there we go. We are hooked up at 10:10:156. So let's bring up a browser to 10:10:156. And I'll put in my MQTT information. .156. And I remember we were talking about I want to say it was on the last stream, they were talking about putting the web access password on the Tasmota devices. And I actually put them on all of mine because in case that rare time, like when I'm upgrading firmware on my access points where they're falling off the network for temporarily, well, they could flip back into access point mode. And I don't live in apartments or anything like that, but in case they do, some device or somebody happens to connect to it, and they could, you know, hit factory default or something like that. So I just like to put a real simple password. It's nothing crazy, and I put the same one on all of them. And it's just more of a, just a, not security wise, but just to stop anything stupid from happening. So now we're in here, and we're gonna leave it as the Sonoff basic module. We're gonna try that as the basic module, but we'll just have to figure out what it does. So I'm gonna go to configuration and put in my MQTT, because I can see it delays a little bit without an MQTT setup. Let me set that up right quick. Put my password in for that. And we'll call this MJ Switch 1. And I'll come back and I'll show you what I put in here. So main menu, we'll go to configuration, and I just filled out my stuff and put called it MJ Switch 1. I left the full topic. Let's see if I can get this on the screen. I left the full topic as the prefix topic. I don't mess with any of that usually. So at this point, did it drop off? No, we're still good. At this point, what I do is go ahead and pull the USB stuff off of it. And before I unsolder those wires, which I guess I shouldn't have turned the soldering iron off, is I'll cycle the power one time on the unit. So we'll cycle power on it in a second. And I just want to verify it is going to pop back up on the Wi-Fi and not have any issues before I unsolder the wires from it, because I don't want to solder them all back again. Too lazy to do that. Yep, so we're good. Configuration, yep, we're good. And let's just see, main menu, information, and yep, we should be all good. So we're gonna pull power, and we'll turn this off again. We'll flip back to the camera. And we'll pull our pins off. Not like that, Travis. Pull that back off. Put that away. And take our wires back off. Now I can tell you what would be cool, and why I'm waiting to warm up here. You guys with all the cool 3D printers and stuff, is y'all need to make a cap that will go, you'll have where you can attach the pins to it, because all these modules are the same and you can get to them. So you guys need to make a cap that, because you just got a lip on it, you could make a cap that would just click and slide over this module, and it would attach to these pins, and we wouldn't have to solder to them, and it would just have like little holes or something. Even if it had like little holes, and I don't know if there's enough room, that's what I leave you to figure out, if there's enough room, or how would you, because the only two that are close together are these two pins right here, the RX and TX. you may have, those might be tough to put, but maybe you can put little holes and just use a breadboard male-to-male wire and stick that in the end of a female-to-female DuPont jumper wire to put those two together. I don't know. Y'all can figure out something, but it just seems like there's so many of these little modules and all these different switches that it would be easy with a little cap to put on there. Oh, we got it. What am I missing back in the chat? Oh, there's the dock. Okay. See, the dock will just have to go in when he's really, really bored and he's spending time in his new automated bathroom that he, that he could sit and watch this, almost an hour video we spent flashing a switch. So we should be warmed up by now on the... Let me make sure we got it actually focused again, because the focus is going to drive me nuts on this thing. It focuses really good close up. So, but basically what I'm going to do on these is I just take and heat them back up and pull them back off. But make sure you're not touching the pad and short down any of the pads like they were previously done. And I don't pull hard or anything, just a little pressure and pull it off. And sometimes I will touch up the solder just to make sure. You don't want it touching the metal on the can. Not that it's going to stick anything else up. And let's pull these out the way. And pull that one out the way. There we go. Last one. And I gotta clean up that solder. It's got a big old thing sticking off. We should be good. Make sure and turn the iron back off. Can you show what the mains board? Yeah, when I put that back together, we'll show what that is, and we will wire that up to mains. I don't think I have a light actually to connect it to show, but that's, you guys will get that point. That would be kind of boring anyway. Because I do want to show something else that's pretty cool. So this is already going pretty long. If I've lost anybody, so turn the autofocus back on. We do have a little bit sticking up there, but that's fine. It's not touching anything. Like some shark fins now, but big deal. We're not touching anything else. We're not touching the can. We're not touching any other. So then we should be good to go. So looking back at the inside, the main side of it, and I'll get a good shot of it. Here's the inside of it. It is a 16 amp relay. You guys know more than me on this, I'm sure. Some capacitors, Zener diode in the back, resistor. So I'm just going to show that kind of enough for you. So really easy. Let's put this back together. Let me zoom out a little bit here. My redneck zoom, right? But whatever works, works. And luckily, they thought of me and made it where I couldn't put it backwards with the screws. So put this back in. And we won't tighten them all down at first, in case one of us gives us an alignment problem. And get them out of my imaginary dish, right? Found what works really well too for those screws is on accident is a cap to a water bottle. A little clear cap to a water bottle has worked fine for me before. And just worked in a pinch and I had it sitting there. Alright, we'll snug these up, not too much because you don't want to strip the plastic out. Just bump them down. And that's it. The little reset button still works. I don't know if you can hear it. The reset button still works. That's actually kind of a cool idea, unless the kids figure that one out. But it won't reset the Wi-Fi or anything. The button still clicks. You can see it pushing the button inside. I don't know if you can see enough light. We're good to go. I'm missing anything on the chat? Nope. Okay. So let's move all this junk out the way, and we will attach it to mains power after we put this back together. Move some of my lights here. And just a little 3-pin deal, and it should snap in. I'm sure there's a real name for this actual plug. Where's my screwdriver? Yep. Next. Just make sure it's plugged in. Make sure it's clicked on all sides. Don't need it coming out. Yep, we're good to go. And I need a mains power wire. 1 second. One thing I forgot. Alright, let's put this back together. Sure, we'll start over with. Only took us 1 hour and 7 minutes to get here, right? So put this, but you can always we can rewind and watch later. Me fumble with my soldering, and now watch me laugh at me and try to fumble with this ground plate here, which didn't make a difference really for me because everything I have is plastic boxes. Make sure I'm not pinching any wires. No, okay. So it should be, pop it back together. Boom. And there's a little protective plastic on here, but we won't peel that back just yet, right? So load is brown. I'm just gonna cap that off because, like I said, I don't have a light available right now. A whole setup and a plug to do it. I've got to actually tie it to something else, which I'm hoping to get to be able to show you guys. Actually, another dimmer. Hopefully I get to show you. So this is our black. And we don't need ground, but I think I have another wire nut. I should have one in the box, right? Neutral. And green to green. Not that really matters, but we'll just do it so don't touch anything else, right? So we got our brown, the load tied off, and we're good. Let's fire it up. And the ground thing came out a little bit. There we go. To pop that piece back in. Let's fire it up and let's see if the smoke comes out. How about we use the plug with the soldering iron was in. And let me turn the soldering iron plug on again. Bench delta. All right. Let's see now. Turn the screen back on. And we don't need termite anymore. And hit refresh. Sure enough, she's ready to go. So we're good. No smoke. So we'll leave it as sewn off basic. Let's just try that. Oh, got lucky. Toggle. And I can hear it toggling the relay. I don't know if you can hear it. But now I'm curious of, is it an inverted relay or not? Now I kind of wish I did hook up the light. But let's just throw a meter on it. Let me turn it off first because I do not know what state that relay is in. Let's see, let's hook up the meter to the brown. I'll slide the other screen out in a second. And should be able to use common there. And let's turn it on. Alright, let's see if you can see this without me disconnecting anything. Alright. So it's actually not, which I didn't expect it to be, but you never can assume that the relay was inverted or not. So on is on and off is off. That's what the inverted would be, that if off was on and then on, you know, they're backwards, you would actually put it as an inverted relay. But it looks like we don't have that issue here. So we'll just leave that on. It's a good indicator for a light, right? So for the LED, I can't tell. I don't see an LED coming on. No. So, show you a real cool trick. If you want to go look for the code, well, it's already in there actually, but I'll show you one thing you can do if you're ever curious of what these different templates are, is if you go to, and I know I went kind of quick, I'll go back. If you go to the code and go to Sonoff, the Sonoff folder, and you go to Sonoff template.h, and you can either do a find or a search. Scroll past all where they're lining up the thing. Look for these where they're all laid out. And this is all the templates. And you can see the Sonoff basic, the relay is right here. That's GPIO12. So we know we want to use that one now, but then we got to find out what's the LEDs. Remember we had the there was a 2-color LED. So let's find that. So what we'll go back here, go to configuration, configure module, and we're going to change this to generic. And we'll save it. And we'll go back to configuration, configure module, and go to GPIO12. We'll set that to relay 1. And I know I done forgot. I should have wrote those down. Is the pinouts on how this thing was, but we'll just do it like this and figure it out. So let's just see if this is actually, I never checked to see if the button was actually GPIO 0 or not. I should have done that while it was on there. So I want to say it was GPIO 15. No, it wasn't 15. I don't remember. What I'll do is I go in here and I'll do like relay 2. I'll do relay 3. And I'll do like relay 4. And it may be enough for me for now. And what I'm trying to do is just I'm hunting for those LEDs. So we'll see if we can find. Okay, that's going to be the regular relay. Nope, I don't see anything. Don't see anything. And don't see anything. Okay. We got unlucky. Let's see. Let's try. I'm keeping it up to y'all to figure out which ones we did already, right? Y'all know that. We'll get off 14. We'll get off 13. Let's see, we need relay 3. And relay 4. I'm not going to do serial in, serial out, because we know those are correct. Those aren't used for the relay, for the LED. And we'll do relay 5. Let's save them up. Alright. Oh, I got something different now. If you can see, let me turn one of these lights out here. Of course, the camera's going to compensate. You can see we've got purple, which is going to be multicolor, so it's probably going to be inverted. That's the regular relay. It's 2, 3. Oh, okay. That's probably what, blue? So whatever we did for relay 3, remember that. Somebody write that down or write that in the chat. We'll do relay 3. Relay 4 is, so we did relay 3, there they are. And so relay 4 is the LED and it's not inverted, but then relay 3 is going to be inverted, I believe. No, it does different. There we go. Actually, they're both inverted. Yeah, they're both inverted. So we do relay 3 and 4. So configure module. So that's actually going to be D1 and D2. So we'll turn that off. And we'll do relay 2, relay 3, and just for kicks, because I didn't do anything with it, I want to make sure what D4 wasn't anything. Oh, I forgot to put them inverted. No, that doesn't do anything. That's fine. So we'll do this one to none, and we'll set this one to relay 2, and then we'll figure out which one we want to do for LEDs for the status, which kind of a fork in the road. You can figure out what you want to do. So main menu, and there we go. You got, I don't know if you can hear it, but I can hear the relay clicking on this one. And then there's your blue light, and then there's your red light. So let me turn the lights back on here. Blow out the camera. I'm gonna do something kind of cool here. Is we'll do let's do something different. Let's do configure module, just because we can, right? Is we'll change, and I forgot which one was which. Is relay 2 is blue and that one's red. So I'm gonna change the number 2 to actually the LED 1i. So that's GPIO5, and that's gonna stick with the status light of the switch. And then I'm going to change this one to PWM. I think that should work. Let's turn the lights out again on here. So what we have here, turn the light on, and I do have my LED state. Let's see, LED state 1. I wonder if it is being, and there it is. Let's see. So now we can see, in the LED state 1, I believe that's the default. I think I had mine going to MQTT messages as the default. So it's your normal thing here, but I want to try and see. We should be able to do this. Interesting, it's going to pull the blue in as well. Because it's backwards. I wanted to see what we could do with the PWM on it, but that's fine. We could do, like I say, you can play around with this and do whatever you wanted to do, and you don't necessarily need it. I wonder if it lets you do LED 1 and 1i, like if it would alternate. I'm not sure if it will. Like where you have it red when off, and then no, I think we could do that with a rule and right into a different LED or something like that, but I changed it wrong, didn't I? LED1i, I think is what it was. All right. Yeah. But we could do some rules and stuff, but we're pretty much having beat a dead horse, as you could see on how to do that. If you got any questions about it, let me know. But you can see that's basically straight from, I've never unboxed that switch before, and just pop it open. We can solder to it, back up the flash. We can identify the flash, go through, and then you can saw a little bit of trying to figure out the GPIO pins, and just setting up as a basic. And you can configure whatever pins you want. So you can, which is kind of neat on this one, you can control the status lights. So if you really wanted to, you could assign those status lights as other relays and leave them like that, and they would actually be as switches, and you could change the color of the light from different automations or whatever you wanted to do. So let me move this all out of the way, and I'll show you something pretty cool that I have been messing with. Let me turn the display off, and we will focus the camera again, because the autofocus sucks. So let's turn all this off before we start grabbing around, right? Alright, got that off. And we'll pull all this out the way. I got a spot for that switch as well. I can go put it in later. Pretty cool switch. Got a little more to flash. I mean, you got then like those KU LEDs, but so before I jump to that, you'll notice this looks pretty close to what, I'm trying to get this on the camera without being blown out, and I'll pull up in on this. I guess before we jump to that, everybody, do I need to show how to put it in the Home Assistant, or that'd be everybody be kind of wanting to go to sleep on me? I don't think we need to show it, right? You can just go into the Tasmota Home Assistant side, the wiki, and I'll leave this in the description if you need. I'll leave a copy of a sample of this right here to throw into your let me scroll it down here a little bit to throw into your YAML under your switch or a light or whatever you want to do, and just replace the topic and everything. But I just figured we done beat a dead horse and all that, and you can go look through some of my other videos if you need help putting that in there. So we'll turn the display back off again. So yes. So this one's pretty cool. It's actually also made by Martin Jerry, and you'll notice this time, and I'll get some closer shots. Like I was showing the other one, they used the same mold. There's the status lights, but these status lights will be filled this time. And let me take a sip here. But what's really cool is the same thing. It fits. So here's the first cool part. It's the mains. It is a mains dimmer. It does work with LEDs as long as the LED are dimmable LEDs. and it does fit in a regular Decorah switch plate. So there's no having to modify or anything. Of course, if you had a 3-4 gang, whatever, it'll fit. So cool. Then what was neat about the design, and I know it's not spring-loaded right now because I got it out of the switch. Same deal, you got 4 screws, and you can see it's the same little 4 pattern, but it's a rocker and a rocker. You still got the reset button here at the bottom. As we found, that was the restart, which is tied to the reset pin on the ESP. Same exact design where it's got the little button right here. Let me pull in closer to this so y'all can see. And let me move this. Let me see if I can turn this light out and make it better. Yep, that's better. So you can see it is going to be spring loaded once it's actually together, but it's a rocker, up, down, and a rock, and this whole thing is the rocker Decorah switch as well. So it's kind of like 4 buttons. You've got the reset down here. It's just a reboot again. And then you've got the on off, and then you've got the up and down for the dimmer. So make sure this isn't on before I grab onto it here. So the dimmer, and same kind of general deal. There's that plate for the ground, and I'll try to zoom in here and put this on back on autofocus. Is kind of the same concept, except they've gone to dimming. Except there's a 4-pin. I keep my finger out of there. It keeps getting unfocused. There's a 4-pin pin switch that goes through extra electronics, and you can actually see on this wall, if it'll focus. Now you know why I hate autofocus. Drive me nuts. And then you can see actually the MOSFET is actually right there, and it uses there's this whole plate as the heat sink in the switch. And then you got the relay actually right, I believe it is the relay right here for the dimming, to cut the dimmer off. So now the switch plate is a little different. And the Tuya module that I did before, and if everybody should know that one, that's this guy here. That was the original one, and this one is cool, but of course you have this problem. I don't know why they designed it like this. Now they do give you a single gang faceplate that is, I believe it is screwless, I think. Yeah, I think so. But if you want to put it in a 2-gang, now you got a problem. Now you got to take a Dremel to this and carefully cut it out, and then you got to fill in the, because now they've curved it, so now you've got to try to make this match. But this dimmer is kind of cool because you've got your regular on-off button. And then this is a capacitive touch LED. But the one problem with this is all the ESP chip in here does is it's really it just acts as just a radio. And it sends the Wi-Fi commands back and forth. So, because actually what happens when you turn this on and off, it actually doesn't send a command to the ESP chip. It actually sends a command. There's another microcontroller inside here. And then that microcontroller tells the ESP chip what's going on, and then of course the ESP chip, once I did the code for Tasmota, it sends it over to Tasmota, and then so it talks back and forth. Well, you can't change some of the things you couldn't do. You couldn't do a long press for like turning on something else. You couldn't change the dimming scale. You couldn't change the dimming speed. You were kind of locked in with what in here, which is still a cool switch and for dimming, because we didn't have dimming on Tasmota, with MQTT and everything for a while. But this one's a little better, I find. Like I said, your mileage may vary. Well, the board to this one, as you can see, is very similar to the one we did, and same module, the same module that the U3D printer guys are going to make a jig for, right? Hint, hint. And send them to everybody, right? We'll test here first. But the cool part is let me, and I'll zoom. Let me change these. There we go. The cool part on this is, remember, because it's a rocker and a rocker, is you've got now, here's the on off, here's the down, here's the up, and then you've got 5 status LEDs along with another LED down here. Well, the cool part about this is, and I can't take all the credit for this, I had been working on this for a while, and I kind of got thrown off of it. And one part that kind of stopped me dead was, this isn't the same one. As you can see, this one's in the graveyard because I let the smoke out, and you can see it in the back there. This one got smoked out. I don't know. There's quite a bit that's burnt inside here, but when I was pinning and probing on trying to figure out the communications between this microcontroller that actually does the dimming and the ESP chip, well, I ended up smoking this thing. So I bought another one, and I was a little more careful this time and didn't let the smoke out of this one yet. So I don't know if I put everybody to sleep yet. So the cool part about this one is that a guy named Hank, I don't know who actually Hank is, and I was shown by, I don't know everybody's handle versus their names, Fox1531 on the Dr. Z's Discord channel. He'd been talking, we talked offline, not offline, but I guess on the side of about this dimmer, and I just hadn't had time to mess with it. Well, he sent me the link over to the Tasmota other devices, and I'll pull it up here and I'll send you the link to it. Pull it up over here, and we'll pull up video capture. If we go to the wiki, and let me pull this screen back over here without dragging the whole, whatever. If you go down to other devices, and you'll actually find it right here. There's Martin Jerry MJ SD01 Smart Dimmer, and I'll post a link to it in the chat here. And looks like they are $23.99 right now, so $24 for a dimmer. Not bad. So he posted kind of the same thing. He did note that the chip is backwards. Hank did a pretty good job. Maybe eventually Hank will contact me. Whoever Hank is, I saw it was the last person to edit it. Did a pretty good job and went through. And noticed one thing he talked about was the purple wire, or the blue, whichever you want to call it, which was the one I was looking at. I thought it was actually going to be some sort of serial connection. I guess kind of like I figured it was the other two, but it actually, and he was right. I put the meter on it. It's actually a PWM signal. And one thing, I guess another thing that made me not mess with this dimmer for a little bit, I wasn't really impressed with the dimming with the stock firmware on it, and I thought we were kind of locked into it, like with the dimming rates on that OIDM to you module one, because it would just seem like it was like a low and then almost like a high, and I was like, well, I don't know if that's really any good. But when I found with this, and let me plug it up and I'll shut my mouth. That may be hard to show actually on the camera. Is the actual dimming rate. Do you have any plugs that you're testing? Plugs? Not really. I've got some S20s. The S20s work great, and I've got some S31s. But no, just some other plugs. I'm not too much of a plug person because I've got most of my plug things done. So, so let's plug this thing up, and I'll show you how this works. Now, and it gets kind of crazy. All right, we're plugged in, because what's different about it is you have to control, and this is going to take probably some code changes, is because you've got the 5 status lights. Well, the 5 status lights, if you remember, they're on the switch here, and they're going to be lit up green along the side up here, so that you know the dimming level. So let me turn this thing on, and I'm just double checking to make sure I still have stuff hooked up before I fire up mains voltage on it. I got brown to there. I do have another lamp with a LED equivalent 100 watt bulb in it, and what we'll do, that's the Charlie. Alright, and I need to find the IP address to it, so give me a second. On the Unify controller, I hope it's still got me logged in, and there it is, 192.168.1.176. Alright, and let's see if we can all get this in frame. Display, and I'm gonna slide the camera, slide this one off to the side here. We still want to see the console a little bit though. So, and we'll bring the dashboard. No, PWM, that's the pulse width modulation. 1 second here, excuse me. PWM, it's the pulse width modulation. And if you actually look with your regular meter, you really need an oscilloscope to see it. You plug your regular meter up to it, and it actually looks like because it's cycling it off so fast, it looks like it's just lower voltage. And so kind of the same concept with your eye. You can do pulse width modulation to an LED, and it's actually flickering that LED very fast. And so it's putting gaps where it's like light, brown, light off, and then your eyes just can't see it that fast, so it actually looks like it's actually dimming the LED, but it's actually not. So it's a real quick concept. You can go Google and go to your heart's content about the duty cycles and everything of the PWM and the frequency and what it does with cameras, and if you don't have this frequency a certain bit, etc. But the one problem with PWM on the ESP8266, the PWM is all software driven. It's not hardware driven. So you'll find as a lot of these manufacturers found that problem with dimming LEDs. And when you got a lot of Wi-Fi traffic to them, or even a low Wi-Fi signal, where the ESP is only one core, so it's having to switch over and do that Wi-Fi. Well, kind of in essence, it forgets how in that it's flickering this PWM really fast, and so you end up with this pulsing, and it kind of flickers the LEDs if you've done just a regular LED on it. Now the ESP32 has hardware PWM, plus there's dual core, has a little more memory, RAM, etc. But I haven't seen anybody using the ESP32 out in the field yet, except on your dev boards. But the ESP32 is really great, but there's no official Tasmota for it. So that's a real quick primer on PWM. So with this, and I got to be careful, I got mains voltage on it. I'm going to try to put this to the side here without smoking anything here. Y'all don't need to see the plug. Give me a second here where I can prop this up so y'all can see the status lights and stuff. All right. And all right. How about we get a little closer where y'all can see status lights. And then we'll turn this light off. That way y'all can see it a little better. So you can see here the configuration of this thing, and I'm not fully it really needs to be done in code. So this is more of just like a proof of concept, but it does work. And one thing I did have to change, I couldn't get Hanks to work. Yeah, live electrocution, right? I couldn't get Hanks to work because it was showing like GPIO16. It was showing like a reset or something like that on his. And so at first it couldn't get to work. I was like, well, something's different. So I went back and I flashed the stock firmware. And I went through and looked and went to go see exactly what the stock firmware was doing. And it actually, when it's off, it applies 3.3 volts to the another pin. And so once I did that, I was able to toggle the on and off. That's the actual on and off, but then you have a PWM, and I had to make those follow as well, which I did those with rules. But there's possibility it could get out of sync, and we could do this all with rules, but then you're filling up all the rules, and I don't want to do that. So eventually what I would want to do is this actually in the Tasmota code itself, where you could just pick this for this Martin Jerry and call it a day. So it's a pretty busy chip because, like I say, all these relays are actually the status lights, and those would be configured as some LEDs later. The only open pin is that D4 GPIO2 if you actually wanted to tie something else into it. So you'll notice they do use the TX and RX and the whole 9 yards. So, but enough of that. Let's go to configuration. Back to the main menu. And we should be able to turn on the relay, and you'll notice on my lamp over here, I'm gonna point that down so I don't blow out the status. I want y'all to see the status lights. So that blue LED and the first green are actually attached together. You cannot change those. So if and it makes sense when you're on, you're gonna have it. When you're on, you're gonna have at least the lowest dimming level. So what they did is tied these two together, and so when it's on, this one's on. The first status light is the first level light is on. So you'll notice, even though if I take and go to and I have rules in here, and you notice that whenever I flicked on one, it turns this relay, the first relay, and it turns this one on, because this relay is actually not a relay, it's actually the PWM pin. And if you just turn this one on and you apply PWM to it, nothing happens. So this is some of the stuff that has to be done. I feel would be better in code. But I have it where we turn the switch on, it will kick on the PWM relay, which will allow you to change the dimming. And And I don't know if you'll be able to see. Let me pull this light back up here. If the camera may automatically adjust for the brightness, so it may not look like it's getting brighter. You may see, and it's got a pretty, I feel, a pretty decent scale, even just how it is. And it goes, actually, I know it's hard to envision, it actually goes pretty dim. I haven't put a meter on it to like see how many watts this is actually pulling when it's all the way at the lowest dimming scale. But I did like the number of scale. You know, this is a huge improvement over the stock firmware, and that's me moving the lamp that's not going up and down. It's a huge improvement on the scale of the light, and it's pretty. You can see it's pretty smooth on the dimming and up and down. So, but the cool part is now this would have to be done in software, but I'm even actually thinking a little step further is kind of like if you've seen some of those home seer Z-Wave stuff, and I know we said this bad Z-Wave word, probably going to get struck down and my Z-Wave switch is not going to work tonight, but so if you look at this relay, you see how I've got this is actually, you can control the LEDs. So if you wanted to, you could actually, if you how handy you are, you could change these LEDs out to different colors. You could flash the LEDs using different automations. I have something similar where I've got a panel in my bedroom where it runs which says totally beyond this almost 2-hour video of a Sonoff iFan 02 using another module, and actually I have LEDs off of it for showing different statuses. Like I can tell when a window's open on my house, or I can tell if a door is open on the house, and then also if the alarm is armed or disarmed. But you could do something similar with that, because you can turn these LEDs, and you can see I click number 3, there's number 4, and there's number 5. And number 6, if you watch the bottom light, that's the actual red side of the multicolor on-off LED. If I turn all these back off, and you can actually just make that one red if you wanted to while it's off. But of course, when it's on, that this is hard coded when it's on. These bottom ones are hard coded. So pretty cool little switch. You can see I don't have to put them in order. I did have to do some rules on it to get it actually working right. Is one of the rules I had to do was, and I didn't need the backlog. Actually, I was messing with this. Let me make sure this is all on screen here. And move this over a little bit. So, actually for the rule 1, I had to do on switch 1 state. I had to do a backlog. Like I said, I didn't need the backlogs. I figured out a little different way to do it. I just need to do POWER1 toggle, and that's going to toggle that number 1 relay. Well, you think, what about number 7? And I could have piled these all in one rule, but I was just late last night. I was messing with how to do this and try to get it working. So rule 2 is when on switch 1 is that on and off button. When it's pushed, it toggles it. But then this also, when it sees that relay 1 switch to off, it'll actually take power 7, which is the PWM signal, turns that to 0. Well, then when it's on, it takes power 7 and turns it on. So then, and that makes those 2 follow. Rule 3 is you have switch 3 state, which is the up button, is switch 3. When it's pushed, it's just a 1, it's pushed up, then you have to do dimmer plus, and it makes the dim go up and down, and then when you push the down button, it goes dimmer minus. And if I can easily show, now what's cool about it, now the only that you could do one thing I did think of, and I just didn't do it yet, is I did put in the switch modes, where if we watch the console, and my finger, if I don't get shocked here, but it's all low voltage up here. If I push the on, it does turn it on. You can see power 1 and then power 7. That rule kicks off, so it kicks on power 1 and power 7. And then turn it off. It's going to turn off, based on the rule as well. But you can do a long press. I do have it set for 4 seconds, the default of 4 seconds, I believe. And I don't have the rule set. But if I had a rule set to state equals 3, then you would actually see the message it would send over however you wanted, whatever you want to do with it. Of course, if you want to send send a message to another light or something like that. One thing I did think of was do a long, and you could, of course, the user could change this to whatever they want, because this gives you 3 other buttons, and you could make it toggle 3 other lights in your house if you wanted to, or kick off whatever automations you could, because you could just make these send MQTT messages or whatever. So I was thinking of doing where if you long pressed this one, then you saw it said did dimmer 1, but I must have not pressed it. You could long press and it would do dimmer all the way down to 1. So if you just say the light was all the way up, if you just long press for like a second, then it would make it drop to the lowest setting. And then if you long pressed on the top, then it would go all the way up without having to go and click to get to the levels. But just to show you, it does. We can see this light here. Let me turn this other light back off. And we'll put this down. We can see the dim level a little bit. And try to get all this in frame. And if we do, you can see the dim goes down. And then each level of the button I'm pushing, and it jumps 10 at a time all the way up to 100 and does the dimming. Now the rule, I didn't set the rules in. The next part, what I would need to do, which probably be easier in code, because there's no if statements really in the Tasmota rules, is to go through and set the 5 status LEDs based on what you would want to do. But the user would still be able to steal these LEDs using some rules or something like that. So hopefully we'll do something with that pretty soon. But even out of the box as it is right now, it's very usable. Just the status lights don't work right now. You could, if you really want to get crazy, you could do something with Node Red or some other rules or automations that are based on dimming and flip those back open, and you can make it work right now. And it does, as you can see, it's probably, without a doubt, probably going to be one of my favorite dimmers at this point. I'm sitting here thinking, well, what else can I work? Where else do I need dimming? Because I want to buy another couple of these dimmers. So, but I guess before we wrap it up, is there any other questions? Or I know we may have a bunch of questions. If not, I've only got 18 people we've been dragging on. I appreciate it going this long. I wanted to show you this other cool little switch and the dimmer switch. Hopefully we'll do a full-blown video on that, and I'll actually work that into Tasmota somehow, and we'll go from there. So I'll wait for the